Welcome to This Explainer. Today, we're going to fundamentally shift how you look at everyday science. We're starting with a machine we literally all take for granted. I mean, think about it. We flip a switch on the wall, we hear a mechanical hum, and boom, the sweltering heat of summer is just banished from our homes. Most of us just assume there's a giant fan in there somewhere making cold air and blasting it at us. But the truth of what's actually happening inside that metal box, it is an absolutely fascinating feat of engineering. So let's look under the hood and decode the mechanics of cool.
Let's dive right into the core question here. It's one of those things that seems to have a completely obvious answer, but actually hides a brilliant mechanical secret. Think about your living room on a blistering 90-degree day. You crank the AC and within 20 minutes, it's a perfect, comfortable 72 degrees. If I asked you how that happened, you'd probably just say, well, the machine made some cold air and pushed it into the room. And honestly, that makes perfect sense, right? We have heaters that make hot air, so we must have coolers that make cold air. But that assumption, that is exactly where our understanding of temperature control completely goes off the rails. So, here is the absolute crucial point. We need to totally shatter this illusion of making cold, because your AC is basically pulling off a thermal heist. It is not making cold air, it's actually removing heat. You see, cold isn't a physical thing you can just create out of thin air. Cold is simply the absence of heat. So, to make a room cold, you literally cannot pump coldness into it, no way. Instead, you have to find a way to trap the heat that's already inside the room, grab it, and throw it outside. Your air conditioner, it's not a cold air factory, it's a heat removal engine.
Section 1. The Great Cooling Myth and Changing How We See Temperature.
To track this heat-stealing operation without getting totally bogged down in complex engineering diagrams, let's establish a really simple visual code for our cast of characters. Red is going to represent the heat energy we desperately want to banish. Blue will be the resulting cool air we actually get to enjoy once that heat is gone. But the absolute star of the show, that's green. Green represents the vehicle, the transport system that makes this entire operation possible. So keep an eye out for these colored arrows as we map out the journey.
Moving on to Section 2. Meet the refrigerant, the hero of our story.
Obviously, you can't just scoop up heat with your hands and chuck it out the window, right? You need a highly specialized tool to grab that warmth right out of your room, and that tool is the refrigerant. It's a special liquid contained entirely within the closed loop of your air conditioning system. Honestly, the best way to think about the refrigerant is like a fleet of microscopic dump trucks. Their one and only job is to drive into your house completely empty, load up their beds with absolutely all the heat they can carry, drive outside, dump that heat into the outdoor air, and then cruise back inside for another load.
This brings us to Section 3, the squeeze and release, the mechanical journey. So, let's dive into the actual machine to see how this special liquid performs its heavy lifting. It's basically a continuous mechanical relay race where heat is passed along and expelled from your home. This is the real core of our explainer today. Let's walk through these 4 phases, keeping that green refrigerant in mind. First up, your indoor air blows over the evaporator coil. Inside that coil, our green refrigerant acts exactly like a sponge, just soaking up the red heat right out of the air. But now the refrigerant is holding all this heat. How do we force it to let it go? Well, that brings us to step 2, the compressor. The compressor squeezes the refrigerant really tightly. Once it's squeezed, it shoots over to step 3, the condenser coil, which sits right outside your house. Because it's been squeezed so intensely, it forcefully releases all that trapped heat out into the hot summer air. Finally, in step 4, the refrigerant passes through an expansion valve. This acts kind of like a pressure release valve, instantly dropping the pressure, cooling the refrigerant right back down, and prepping it to head back inside to grab more heat.
I really want you to notice how the refrigerant goes from just casually carrying the heat from the evaporator to being aggressively squeezed by the compressor until it's super hot and at high pressure. Honestly, this right here is the absolute genius of the air conditioner. Think about it. If you just have a liquid that absorbs some heat from a room, that liquid is warm. But the air outside in the dead of summer, it's also warm. And heat naturally wants to flow from something hot to something cold, not the other way around. So how on earth do you make the warm refrigerant dump its heat into the already hot outside air? You have to make the refrigerant hotter than the air outside. By squeezing the refrigerant in the compressor, it forces all those molecules together, drastically raising the pressure and making it incredibly hot. Now, compared to this superheated refrigerant, the hot summer air outside actually looks kind of cool, and that allows the heat to successfully jump from the machine out into the great outdoors.
This totally separates the geography of your air conditioner, and it's exactly why you always have an inside unit and an outside unit. Or, if you have a window AC, a front half and a back half. Inside the building is the collection zone. The evaporator coil lives here, pulling the warm air inside the unit and just quietly soaking up that thermal energy. It's super quiet, it's highly efficient, and it results in those beautiful blue arrows of cool air blowing right back onto us. But outside the building, that is the dumping ground. That's where the compressor and condenser live, and that's exactly why the outside unit of your AC is always blowing hot air and making a total racket. It is out there aggressively expelling the thermal energy it literally just robbed from your living room.
All right, section 4, the continuous cycle, bringing it all together.
So we've dumped the heat outside, but the job isn't quite finished yet. After passing through the expansion valve, the green refrigerant flow loops right back to the start, continuously pumping that blue cool air into your space. Because, this isn't just a one-time event. You don't just pull the heat out of a room once and call it a day, right? The sun and the outside environment are constantly trying to sneak that heat right back into your house, so the air conditioner has to work as a continuous repeating cycle. The refrigerant absorbs the red heat indoors, gets violently squeezed by the compressor, releases the heat outdoors through the condenser, and then, this is crucial, passes through the expansion valve to depressurize and become cold all over again. It's just a tireless, endless loop. Green arrows transporting red arrows out, resulting in blue arrows coming in. It just repeats again and again and again, for as long as the thermostat tells it there's unwanted heat sneaking into your room.
I really hope this explainer leaves you looking at your everyday household machines just a little bit differently. We surround ourselves with appliances that we kind of assume just run on simple magic, like a magic box that just makes cold air out of nowhere. But once you pull back the curtain, you see these beautiful, logical, and deeply fascinating mechanical realities. It's basically a special liquid running a continuous loop of thermal theft. So the next time you feel that crisp cold breeze from your vent, I want you to picture that heat being grabbed, squeezed, and forcefully thrown outside exactly where it belongs. It really makes you wonder, what other magic everyday appliances are hiding their brilliant mechanics right in plain sight? Keep asking questions and keep learning.